In this experiment, we will design basic arithmetic operations such as addition and subtraction of 2-bit and 3 bits. We are using AND gates, OR gates, NOT gate, and XOR gates for building this circuit. The circuits can be simulated in multisim as shown here, and check the truth table. For the half adder, which will add 2 bits X and Y and produce 2 outputs, sum and carry, when input is 0, 0, output sum is 0, and carry is also 0. When any one of the inputs is 1, the sum will be 1 and carry will be 0. When both the inputs are 1, the sum output will be 0 and carry output will be 1. For the half subtraction, there are 2 inputs X and Y and 2 outputs difference and borrow. Here we're doing X, Y. When X equals 0, Y equals 0, then D equals 0. When B equals 0, X equals 0, Y equals 1, then D equals 1. B equals 1 when X equals 1, B equals 0, then D equals 1. B equals 0 when X equals 1 and Y equals 1, then D equals 0 and B equals 0. The full adder is a circuit which will add 3 bits, X, Y, and Z, and produce 2 outputs, sum and carry. The sum and carry outputs will be 0 when all the inputs are 0. The sum output will be the 1 and carry output will be the 0 when one of the inputs is 1. When 2 of the inputs are 1, the sum output will be 0 and carry will be 1. When all the 3 inputs are 1, the sum and carry will be 1. You can give all the possible conditions and verify the truth table. For the subtraction, the circuit will take 3 inputs, X, Y, and Z, and produce 2 outputs, difference D, and borrow B. Here we are doing the operation X minus Y minus Z. When X equals 0, Y equals 0, Z equals 0, then D equals 0, and B equals 0. When X equals 0, Y equals 0, Z equals 1, then D equals 1, and B equals 1. When X equals 0, Y equals 1, Z equals 0, then D equals 1, and B equals 1. Similarly, you can check all the conditions and verify the truth table. Once you complete the simulation, you can do the hardware implementation. First, we are implementing the half adder. The 2 inputs are connected to the switches, and the outputs are connected to the indicators. Indicator 7 is connected to sum output, and indicator 4 is connected to carry. When input is 0, 0, output sums is 0 and carry is also 0. When any one of the inputs is 1, then the sum will be 1 and carry will be 0. When both the inputs are 1, the sum output will be 0 and carry output will be 1. Next, we'll implement the full adder. For the full adder, the sum is connected to indicator 7 and carry is connected to indicator 4. The sum and carry outputs will be 0 when all inputs are 0. The sum output will be 1 and carry outputs will be 0 when one of the inputs is 1. When 2 of the inputs are 1, the sum output will be 0 and carry will be 1. When all of the 3 inputs are 1, the sum and carry will be 1. You can give all the possible conditions and verify the truth table. For the full subtractor, the difference D is connected to indicator 7 and the borrow B is connected to indicator 4. Switch 7 is X, switch 6 is Y, and switch 5 is Z. When X equals Y equals Z equals 0, then D equals B equals 0. When we make X equal 1, Y equals 0, and Z equals 0, then 1 minus 0 is 1 with borrow 0. When X equals 1, Y equals 1, and Z equals 0, then 1 minus 0 is 0 with borrow 0. When X equals 1, Y equals 1, and Z equals 1, then 1 minus 1 is 1 with borrow 1. Similarly, you can check all the other possible combinations and verify your truth table.